Hi everyone, welcome to join today's webinar session, StorageQuery, Federated Querying on Object Stores powered by Alluxio and Presto. We will start in a few minutes. Before we start, I want to give a little bit intro on the logistic. My name is Ben Fan. I am the maintainer for Alluxio community. I will be your moderator today. So before I introduce you to our speaker, I have a few housekeeping items. All participants are automatically on mute throughout the session, and we will be using Slack to communicate. I already invited all the registrants to the Slack channel, so please check your registration email, and you should receive an invitation already. Please take a moment to join us on the Slack community channel, which is copied also as alluxio.io/Slack. I'm copying this to the chat box. So this is the venue we do Q&A. In today's session, you will have a Q&A session in Slack, so we can answer all your questions there, and you can always go back to Slack to retrieve your questions. And yeah, that's all I have today. Today's session is recorded and will be available for on-demand playback. We will email you the link to the presentation as well later on. I believe that's all the housekeeping items. And in a few minutes, let's meet our speakers. Cool, I see people are joining this webinar room. So let's start. Today we have speaker Gabriel and Abner from Simbiose Ventures. I will have Gabriel and Abner introduce yourself, and we can start from there.
Wonderful, Bean. Thank you so much for having us. It's a pleasure to speak to the Alluxio community. We are not a very big company like Facebook or like many others that have been talking with all of you before, but we will do our best to show how we are using Alluxio, improving Alluxio, learning Alluxio, and the cool stuff that we are doing with Alluxio. Should we start, Bean?
Yeah, go ahead.
Wonderful, excellent. So let me just share my screen, 1 sec. Yeah, I believe you guys can see my screen, right?
Yes,
wonderful.
We can see you. Yeah.
Thank you. So, I'm Gabriel. I'm currently the Simbiose CTO. Simbiose is our company, and I will tell a little bit more about the company in a few seconds. But my role here within the company is really to evaluate new technologies and also to discover how we can better optimize our systems, reduce latency, and a normal role for a CTO, but especially challenge in a small company as we are. So a quick overview about the agenda here. I will briefly talk about Simbiose, then about our product, or one of our products, that is StorageQuery, that is heavily using Alluxio under the hood, how we use Alluxio, and the main advantages of doing that, the technical integration itself, and how we develop the Alluxio Debug Log, or in another word, how we learn Alluxio the hard way or the easy way. And in the end, I will also share some of our other projects that we are also using Alluxio as an important part or as a huge benefit. So let me start talking about a little bit about Simbiose. Simbiose, it's a Brazilian company. It's kind of a different company. We are a team of almost 40 people, 90% developers. We kind of have a different concept of regular companies. We tend to select and recruit Brazilians from remote places. Most of our team are normally people from low income level. So we really recruit people that are good by the heart, and we train them programming, databases, distributed systems, and everything they need to do or learn in order to build the systems we kind of develop. So we normally don't work with senior engineers. We tend to form our own team. Right now, obviously, we have senior engineers in our team because have been working with us for several years. But we like to form people, especially people from the low-income class of Brazil. So this is a mix of challenges. We are a technology company, but our main focus is basically on people. We love people. Talking about StorageQuery. So StorageQuery is, some of you might know a company called Amazon, obviously, but especially a product called Redshift and Athena, right? So StorageQuery is an alternative to Amazon Athena. So it's a federated query system using Presto and Alluxio, right? So basically, Athena is a way for you to query on-demand data storage on S3, on Amazon S3. But there are many other storage providers like Wasabi, like Backblaze B2, and those solutions, they until we developed StorageQuery, they didn't have any way to basically query data, to do analytics or to do data lake and so on those platforms. And there is a substantial cost gain by using Backblaze or by using Wasabi, for instance, compared to Amazon S3, right? And especially there is no vendor lock-in, right? There is no lock-in using any of these providers and us. So in summary, StorageQuery, it's a query as a service that basically, or it's a solution that allows you to query data storage right now in Backblaze B2 and Wasabi, and you only pay for what you query. It's basically the same model as Amazon Athena. Most of our customers, most of their use cases are related to data lake, so building a data lake in a cheaper place like Backblaze or Wasabi, and also log analysis. So most of our customers, they store a lot of clickstream, social media, sensor, IoT, server logs, and so on in a place that is very cheap, that are basically object stores. And they use StorageQuery to make this analysis, to make analytics on top of it. StorageQuery is initially developed really for developers. We tend to, at Simbiose, we tend to build our products, especially developer-oriented. So it's fully SQL, it's fully API compatible with JDBC drivers as well. It has some advantages like schema discovery, schema detection. So different from Amazon, for instance, you don't need to go there and declare your schema. We can automatically identify all the schema and the files and the rows and the columns, store it on the object store. So it's really a seamless application. You just need to plug your buckets and you're good to go. This is a quick demo of StorageQuery, just an overview for you to have a sense about how it works. So on the left, we have the buckets. On the right, you can execute queries on these buckets. You can also make joins across multiple buckets and even from different providers. So you can have some data stored on Backblaze B2 and other piece of data storage on Wasabi. And you can make a join, a single query doing a join using, all data available, right? And obviously the great success of this product, or the reason for this product to be quite successful, is Alluxio, right? It's I would say our secret sauce here. And the reason for that is we had to do a way, or to have a way to cache or to make this our customers' data really quickly available for Presto to query, right? And So we have, I will show you in an instance how, quick overview of how our infrastructure work, but we had to have a way to really get the data out of the object store or to have it cached locally, so the query, the analysis would be faster, would be much quicker for our customers, right? No one wants to use it or to wait few minutes to wait for a query, right, to execute. And this is exactly how and why we use Alluxio, right? We have a few clusters of Alluxio because we have few multiple data centers running Alluxio, where we basically cache all the buckets, all the files from our customers from these two object store providers, B2 and Wasabi. And this is a huge boost. If we remove Alluxio out of the equation, if we remove Alluxio from our infrastructure, the time of the queries would increase at least 3 times. So it's a huge boost for our customers to have Alluxio in place. Obviously, this is a full transparent thing. Under the hood, we are using Alluxio, but our customers, they don't necessarily know about it or care about it, right? We care about it. So how it works under the hood? Basically, we have an API layer that controls everything. So that works as the main interface for the SQL, JDBC driver, the API dialect, and so on. That also interacts with Presto and Alluxio. We also have a service that we developed called Data Job Service. And basically what it does is it accesses all the object store providers and map each one of the buckets to Alluxio and constantly update Alluxio, removing from cache and adding to cache all the files that appear here. And the Data Job Service is also responsible for mapping on Alluxio all the file structures. So it's keeping Alluxio up to date and also being the service discovery. So when a customer base adds a new file that contains a different structure, we use Data Job Service to automatically identify the table, the columns, and obviously get a sense of the rows. So our customers can easily query data without having to map the entire database structure, right? So this is a fully distributed service. We have a few clusters of Data Job Service running, and it interacts directly with Presto and Alluxio. As I said before, we have few clusters of Presto and Alluxio, but one important thing is that Presto and Alluxio are working on the same server, right? So we installed Presto and Alluxio on the same servers due to the latency. So it was not necessarily, Presto didn't need to go to the network to get the data, right? You can get data locally. So in a summary, I would say that basically what is happening here is when a query is fired from the customer, so that when a customer executes a query, it goes through our API, and it's directly directed to Presto that will call Alluxio, and obviously these files are automatically cached on Alluxio. If not, Alluxio will get the files directly from Wasabi and B2 according to all the permissions and to the configurations of what file is accessible for each customer, right? So the API here also works as a layer, a permission layer. And the cool stuff is that as we are using this API as a centralization for everything, a central point, we have full control. Doesn't matter the source of the data, we have full control of who is doing what query. And so what query was executed, who did it, when, what was the result. You can even cache it directly on Alluxio and so on. If you want to create a data lake and just give access to just a small portion of the data in terms of rows or in terms of column, this is totally doable, right? So we have this full control here. So basically, this 3 servers or 4 servers work in conjunction to provide StorageQuery. Please feel free to interrupt me at any time if you have any questions, okay? One of the things we had to do in order to, launch StorageQuery was to contribute to Alluxio. So one of our first contributions was the source, Backblaze B2 source. So before Alluxio just had a few sources to Google, Amazon, and a few others. And Backblaze, that is right now an important player in the object store world, was not one of them. So our team really focused on implementing this new file system storage option. And the current state is it's basically ready to, or almost ready to be merged. We just finished the implementation of write support. So I think that in the next few days, this should be merged to the master. But the main thing we had, and the biggest challenge for us, was to learn Alluxio. Because one of the main missions we have, or main rules, I would say, we have at Simbiose is really to only use a third-party technology or a third-party platform if we become committers. We suffered before using third-party technology where we were not committers, and when we faced problems in production, basically we didn't have support and so on. So we long time before we established a rule that any technology we would become committers. And Alluxio, the same as Presto, is a huge product and a huge project, and it's kind of really complex too, right? Because it involves kind of database concepts, distributed systems concepts, and so on. So we thought a lot about how we could learn Alluxio in an efficient way, right? So we could become friendly and being in the shortest time possible. And the main goals, obviously, was really to understand Alluxio's architecture, in the future, help Alluxio's team optimize for amount of files, because we do have a huge amount of buckets and huge amount of files, and also read and write latency, right? That is one of our specialties here at Simbiose, and I will explain why in a few slides. And clearly add new sources such as Backblaze B2, because we want to increase the number of sources supported by StorageQuery. And finally, improve the multi-tenant support, right? Because right now, StorageQuery, it's a solution that it can provide the service for multiple customers, for multiple enterprises from the same servers, the same infrastructure, right? So how we did it? We found, I would say, a technology or a concept called aspect-oriented programming. We studied a lot about it, and AspectJ was the selected one to help us. AspectJ is really, really cool because it helps us or allow us to change the bytecode of any existing Java program during its execution. So how we are using AspectJ? We implemented a library that basically abstracts AspectJ to create a logging system for injecting a log for each one of the methods executed by Alluxio. So what I'm trying to say here is that once you execute the command fs mount, for instance, this abstraction we created with AspectJ allow us to easily and automatically inject something before and something after the method is executed. So we can clearly log everything that is happening within the Alluxio code for each one of the commands, for each one of the functions of Alluxio very easily and without having to put print logs or put logs within the code, what would be very, very messy. So once we instrumentate this I would say plugin that we created and start Alluxio, any command that we execute, basically we will log all the methods that were called during this execution that we call flow, right? So this is an example of how it works. This is a summary of how the log works. So normally we print debug as the standard Java, the flow name, and we define flow name for each one of the commands or each one of the flows supported by Alluxio, for example, fs mount, mount, or unmount, and so on. We have an execution ID that is unique per execution, and a step ID, and the step ID is basically the number of the step for each method. So each method executed has a unique step ID. It's a sequential number. The method execution time, so how long it took for the method to execute. The method name and with the signature, the method signature, so the full method, including the method signature. And finally, the path to the code. So we can easily find what is the file that hosts that method, or where the method is basically stored. So this is a clear example. So when we execute the fs mount flow, we generate a unique execution ID. This is the number of the step ID. So basically, this is showing the method 9,321 that it was executed. This method took 6 seconds to execute, so it's a long time. And this allows us to clearly see the main problems or main performance penalties of Alluxio, and then later on use it to optimize Alluxio. The full method name with the signature, and finally, where this method belongs, where I can find this method in the code. And you're going to understand in this slide why we do that. We later on, once we have this log, we created some way, a way for us to summarize it, because obviously many methods executed during the execution flow are duplicate, right? They are loops. And we had to have a clear view or a summary of what is going on, removing all these loops. So we created another script that basically reads all this log and create a clear and concise summary of what is going on. So this is a clear example of SF mount. It takes the method name with the signature. If the method is in a flow, it shows that the method is in a flow or in a loop flow, the file where it belongs, and finally the Java docs. So this script that we created, it go in the code and try to get the Java doc. So the main purpose of this script and this entire process was to map the execution code or execution flow of Alluxio code, then get the Java doc. But then obviously we noticed that the Alluxio Java code was not very complete. So we started a process, we started initiative to improve Alluxio documentation, heavily improve the Alluxio documentation, starting with all this Alluxio's command. And this is the pull request number currently pending. But this is an example of the documentation we created. So basically what we did is we got a list of all the unique methods executed by each one of the flows, so each one of those commands, and we started documenting each one of the methods one by one, right? Because in the end, our intention is to generate a full document that will show step by step, method by method, sequentially, what is going on and what is the Java doc. So what is the purpose of this method? So the goal here is to have a final document that we can read and clearly understand what is going on in many details for the FS mount or for all the Alluxio commands and all the Alluxio flow, right? I think that this was our approach to learning Alluxio. It's very, very pragmatic approach, I admit, but we believe that once we have all these documents ready, so once we generate all these unique documents, this will be an important thing for the community because it will give a full understand of the Alluxio execution flow for all the main methods or all the main system functions, and will allow many people to contribute more, to understand more about and contribute more to the Alluxio ecosystem. And also this will give us more guarantee that we really understand Alluxio, how Alluxio works under the hood. So about our other projects, we have few other projects at Simbiose. So StorageQuery is one of the projects, but we have few others. One of them, and it's the main project inside our company. It's called ShannonDB. It's an honor to Claude Shannon, obviously. It's a database that we developed from scratch in Java, but that the main purpose or the main focus of the database is to compress data as much as possible, close to the theoretical limits defined by Shannon. Right now, this is not very public. This is the first time I will talk about it in publicly in a webinar. We don't normally say that for anybody because this is very strategic for us. But right now, ShannonDB it has the highest compression rate for a database in the world, much higher than RocksDB, much higher than Gorilla, much higher than Parquet, and so many other compression mechanisms or techniques out there. Basically, for a comparison, a data stored in Parquet in the best possible format, in the most optimized way. If we store the same data in ShannonDB, we basically store the same data in 1/3 or even 1/4 of the size compared to Parquet. So we really compress it. And it's our OLAP database, obviously. So we use that to store data from our customers so they can do very, very fast queries. ShannonDB could be compared to I just forgot the name from the Yandex.
ClickHouse?
It's ClickHouse. Yes, thanks so much, Bean. ClickHouse. It can be heavily compared to ClickHouse, but in terms of data compression, it's for now, ShannonDB is still unbeatable. We heavily invest on that. So where Alluxio fits on ShannonDB? Until now, or until 1 year ago, all the files stored in ShannonDB were stored locally, so in the same server where the server operates, right? So there is no decoupling of storage and processing. And the main project we used at Alluxio, it was when we discovered Alluxio, was really to implement separation of storage and processing. So we used Alluxio to cache or to get access to all the files stored by ShannonDB on object stores. So nowadays, ShannonDB has two modes of operation. One is that can store files locally, but another one that can store files on object stores and use Alluxio to get access to it. So you can imagine if ShannonDB already has a very, very strong compression rate, when we put Alluxio on top of it, it gets even better because we can, instead of using SSDs, SSD disks, we can store that on object stores for less than 1 cent or half a cent per gigabyte instead of 5 cents on SSD, and get almost the same performance of local access. So right now, ShannonDB, because of Alluxio, it's even more special, and I mean, we can store much more data and still have the great latency of queries because of Alluxio. At some point in the future, we plan to release ShannonDB as an independent product. Right now, it's just used internally for our own product, but it's our intention, it's on our roadmap to release ShannonDB as an independent product like ClickHouse or like Snowflake. And that's all. This is what I wanted to share with you guys today, our journey working with Alluxio. It's definitely an interesting project. It's very fundamental for us right now. All our main systems heavily relies on Alluxio. We are learning, contributing, and we really want the community to grow as much as possible. And this is why we are documenting the entire code. This is why we created and re-released this AspectJ plugin as open source. This is why we will generate all this code flow documentation for the entire community. We really want the Alluxio community to grow as much as possible, and because we heavily rely on it and benefit from it. Please feel free to ask me any questions about companies, license dice, how we use Alluxio, ShannonDB, and so on.
Great. This is really a wonderful talk. So Gabriel, I do have a few questions I want to ask you. So for the, I'm very interested in the AspectJ project. You're adding more basically debugging level information into Alluxio execution. So my question here is can we turn on this in the runtime, or this has to be in the compile time configuration?
It's on compile time. It's also possible to do on runtime because AspectJ allows you to change bytecode during execution. So my answer to you is that, can you use that in production? Yes, you could use that in production with minimum overhead, really minimum overhead. Obviously, we generate a lot of logs because we will print whatever you decide to print, but you can either use it during development phase or debugging phase or production, right? The way we develop this plugin is really allows you to say, to configure what you want to print, right? So for example, when we create a new flow, what we do is we define the method that we consider the flow to start and the last method that we consider the flow to end. So everything in between will be logged, right? But you can define multiple rules. You can easily define, okay, just want to log specific methods from specific parts of the code. You can use a wildcard in method names, in package, and so on. Does this make sense?
Yes. Yeah, it makes a lot of sense. So basically one usage on top of my mind is when I'm like in the production deployment, people are asking me from time to time, oh, but then why my execution for this shell command becomes slow. I don't know whether it's because of network or because of the instability for the master node or instability of something else or resource. So like in that case, the reason what I was asking is if there's any runtime flag I can turn on, I can just tell them, oh, you can just turn on this and run the mount command again and send me the log. So I will just have some analysis for you. I can tell where is the problem, right? So yes. It sounds like that is possible, right?
Yes, definitely. It's possible. Would be possible. Totally possible to do that. Yeah.
Okay. Yeah, sounds good. Sounds good. Yeah. So another question related to Alluxio is you have been using Alluxio, but also not only using Alluxio, but also developing Alluxio. So what's your maybe like give me some suggestion or advice? Like what do you think we can do better? In which sense?
I believe that one thing that we really think that we can contribute to Alluxio, or the at least we see as a strong thing we can contribute, is latency. How or latency and multi-tenancy and memory usage. I mean, so everything basically relates to performance, right?
Yeah.
Alluxio is really performant right now, but we kind of use some data structures on ShannonDB. So let's say a simple structure like Cuckoo filter or Bloom filter or many things like that.
That are you using Cuckoo filter?
Say that again.
You mentioned the Cuckoo filter. Are you using Cuckoo filter?
We do. At ShannonDB, we use Cuckoo filter, yes.
Oh, I'm glad. I'm the author of Cuckoo filter.
Excellent. Yeah, we use Cuckoo filter. We use some probabilistic hashing to really reduce the memory footprint and few things like that we believe that we can use in more places at Alluxio based on what we saw, that would reduce network costs and reduce latency as a consequence. Another thing would be to really improve the maintainability of Alluxio on the high availability cluster. I think that we could do a better job. It's great, but we could do a better job in terms of how Alluxio works on the journaling thing and using Zookeeper. We also heavily use Zookeeper at ShannonDB. So so I think that we can improve a lot on that space, and we are eager to help. Yeah.
So I can have some updates here. Actually, would you touch based on all these great topics, and actually a lot of things are already on the agenda, at least for next release or next release. For example, for the latency, Jing Pan, like from our team, he's working on he's leading the internal effort to improve the latency and also basically throughput by analyzing a lot of the performance and see where we can do better in terms of the code, in terms of the resource. So that's definitely one of the top priorities for us. And also for the journaling you mentioned, we will have a very actually shortly in the next release, or maybe even before next release, we'll have the release candidate. We're going to publish a version with enhanced journaling using Raft. Like we are redoing so there are two different modes to store journal and provide availability. One mode traditionally is to use Zookeeper to provide consensus and use shared storage to provide storage for journal. And another mode we are adding in latest 2.0 is to use Raft and to coordinate both journal and for leader selection.
That's great.
So, in the next release, we're going to have much improved version. So previously we're using a library called Copycat, which is one Java implementation for Raft. And now in next release 2.4, we're switching to Redis, which is much more used in industry to provide Raft. So I think like we will have a much more solid implementation for the journaling and also the leader selection in the next release. So all these are very important for us, and like we can talk this offline, but definitely we can see how we can either beta test and also we can collaborate on these different things. These are very essential to this project.
This is amazing. Yes, anything that helps in terms of making the administration easier for high availability cluster. I mean, I don't know how many customers really use HA using Alluxio.
Most of the people are using HA. Yeah, if they use this in production, they use HA.
Right. Excellent. Yeah, this would help a lot and reduce the management cost related to the journaling.
Yep, definitely.
Wonderful.
Yeah, so that's, I think I took a lot of time. Like if anyone from the audience wants to ask any question, actually besides the Slack, there's also a questions box here. So you can type in your question here. Yeah. Anyone from the audience? Like we have 3 minutes left. I think we should take the chance to ask Gabriel a question. This is a great talk. I learned a lot. This is very educational to me too. Yeah, actually, I'm pretty. So Gabriel, just I'm pretty glad you are also using Cuckoo filter. That's my PhD work.
Really? Okay. Yes.
if you check the paper, it's authored by me. Oh, there's one question from from Anuj Jain. How Metastore auto sync different from manual sync Metastore? Is auto sync feature available in community edition? I guess this question for me, this is not Gabriel. Did you talk about the auto sync today?
No.
Okay, so I guess it's So the auto sync, auto sync, I think it's available in community edition, but double check with Jin. He is Jin Pan on Slack. He is the project lead for that initiative. Yeah. So how is it different from manual sync? Okay. So maybe some people don't have the context yet. So in Alluxio, we have the file system, which can abstract away the block object stores or HDFS file system like that. But we also build another layer on top of this file system abstraction. We call the table. We have the table and the catalog service. So essentially, we're building another metadata service to. You can think that is proxy for High Metastore or Glue, and people can connect to people like Presto or Spark, potentially Spark, can talk to this Metastore to get a table level information for the schemas, for the and for the data. Yeah. So for this Metastore, Alluxio Metastore, you can think it's just like Alluxio file system on top of other object store. It's a proxy, or this is a abstract, and this Alluxio table system is an abstract or proxy for other structured data systems. So the Metastore, then we have the problem like how do we keep the data or the metadata inconsistent with each other? In the previous version, we have the manual sync. So once you have, if you're serving the read-only workloads, that's fine. Like once you import Glue or High Metastore into Alluxio Metastore, and you're good to go because data is immutable. But in case you have some data changing over time, and in previous versions, you have to manually trigger some. I think actually there's not even manually trigger. It's you have to disconnect and then re-import again from High Metastore to Alluxio Metastore catalog service. But now I think in the future, I'm not sure whether this is already published or this is in the next release. You should be able to automatically sync between High Metastore and Alluxio catalog service. So there is something like detecting whether there's any change in the underlying table system and trigger updates on the Alluxio side. Yeah, so that's the key idea. Like that's how it is different. But please double check with Jin on whether this is available in the community edition. I just don't recall. Okay. I think we are running out of time. So thank you so much, Gabriel. This is a really great talk. I learned a lot. So let's keep this offline, and we there's definitely a lot of different collaboration we can have.
Wonderful. Thank you so much, Bean, and thank you so much for the entire community for having us.
Thank you.
Thank you.
But if you have any question, Gabriel is also on our Slack channel. Like afterwards, you can always go to the Slack general channel and ask questions. Either tag him or I can help you tag him.
Perfect.
Cool. Yeah. Thank you so much, everyone. Thank you for your time. Yeah. See you next time. Bye.
See you.